Hello and welcome to Forbest Academy, and welcome back to our AMC 1012 preparation videos for the 2021 contest. This week we are looking at the AMC 10 again, and we're going to be breaking down 5 past paper questions, looking at the concepts involved and how we can solve them. And today's question, we're going to be looking at the volume of cones and cylinders. So the question for today, an inverted cone with base radius 12 centimeters and a height 18 centimeters is full of water. The water is poured into a tall cylinder whose horizontal base has a radius of 24 centimeters. What is the height in centimeters of the water in the cylinder? So first thing we need to understand is how to work out the volume of a cone. So for this, it's a very simple idea. We've got our cone here, and we'll draw an inverted cone like they've suggested we have. The volume of this cone is exactly 1/3 the size of its associated prism. So obviously the associated prism for a cone would be a cylinder. So if we considered that this was a cylinder rather than a cone, the volume of our cone would be exactly 1/3 the volume of that cylinder. Now, the same thing applies for pyramids as well. So this isn't just applicable for cones. This can also be applied for our pyramids. So if we consider a square-based pyramid for a second, apologies, it's not the best square in the world. Let's call it a rectangular-based pyramid then, what it is. So if we considered that we had a cuboid, and inside that cuboid, there was a pyramid using the same base and the same height, and we had a pyramid using the same base and the same height, the volume of that pyramid is going to be exactly 1/3 the volume of our cuboid. Now, it doesn't matter where that point is. That point could be in the corner, that point could be in the middle. The volume will always be 1/3 the size of its corresponding prism. So in our question here, we know that the volume of our cone is going to be 1/3 the size of its corresponding cylinder. The volume of the cylinder is worked out by doing pi multiplied by r squared multiplied by the height. And because it's a cone, it is 1/3 the size of that. So using our values from this question, 1/3 multiplied by pi multiplied by 12 squared, so 144, multiplied by 18. We can cancel that 1/3 and the 18 quickly. That's what I do, and turn that into 6, just because we can divide by 3 very easily, and those multiply together to give me 864 pi. So the volume of our cone is 864 pi centimeters cubed. Now, we've also been told that we're pouring the liquid inside our cone into a cylinder, and that cylinder has got a base of 24 centimeters. So again, let's imagine this cylinder. So we're pouring in our liquid, and we want to know what height is our liquid going to reach. So the volume must be the same as we pour in our liquid. So we're still using pi r squared height. In this instance, we don't need to put a 1/3 in front because it's a cylinder, not a cone. And we know the radius is 24. So pi times 24 squared is going to give me 576 pi times by the height. And that must be equal to the amount of water we're pouring into it. So this must equal this. If we divide through by pi, we can cancel off those 2 pi's there. And then divide through by 500 and 76, and we're going to get 864 over 576. And either stick that into our calculator or simplify. Either way, we're getting a height of 1.5 centimeters. Thank you very much for watching our video today. I hope you found it useful, and please tune in the rest of the week for more of our AMC 10 breakdown videos. Thanks very much for watching. I look forward to seeing you again tomorrow.